In this lesson, we are going to find the sum of infinite geometric series. First, we are going to consider a segment 1 meter long. Now that would be the blue segment drawn below this. Cut it in half. That would be the green segment drawn below the blue segment. Cut it in half again. That will give you the red segment. Cut it in half again, and we keep repeating. This is the type of series that we call an infinite geometric series, because even if we keep cutting forever, the sum of all the lengths of the segments will still have to add up to just 1 meter. So even though this series, in other words, has infinitely many terms, it still has a finite sum. An infinite geometric series has a sum if and only if the absolute value of r, or the ratio, is less than 1. In other words, r would have to be between -1 and 1. So if that infinite geometric series has a sum, then the sum is given by the equation s equals a1, or the first term, over 1 minus r, which we know is the ratio. So if you have to write that down, remember a1 is the first term, and r equals the ratio. But if the absolute value of r is greater than or equal to 1, then the series has no sum. That is something important you need to remember. The first thing we're going to want to remember is our rule, or the equation for the geometric sequence rule, which was a1 times r to the n minus 1. So the first example says, find the sum of the infinite geometric series. Notice that this equation is still using the geometric sequence equation, so when we plug our values into our new formula, we will know where to look for them. So if our equation says s equals a1 over 1 minus r, we know that our a1 is 2 over 1 minus r, which is 0.1. So that will give us 2 over 0.9. And if you divide that out, you can, or we could just move each decimal place, take the whole thing times 10, and we will get 20 over 9 equals s, or the sum of this infinite geometric series. So in the next one, we have to find r because we're not given the equation. So remember, to do that, we take our second term and we divide it by our first term if we can't see the pattern right away. So we get that our r equals 1/3. Plugging that into our equation, we get s equals a1, which is the first term, which is 12, over 1 minus r, which we found to be 1/3. So that will give us 12 divided by 2/3. And if you multiply that out, you get 12 times 3 over 2, or 18. And that equals s, or the sum of this infinite geometric series. The next example says that we have an infinite geometric series with a sum of 12 and the first term of 6, and it's asking us to find the common ratio. So this is just working backwards. We're going to use algebra to do that, and we all know how. So we have our formula s equals a1 over 1 minus r. They give us, sorry about that, they give us the sum, which is 12. They give us the first term 6, and we have to find r. So to get the r out of the denominator, let's take both sides times 1 minus r. That will cancel these two out, so we'll get 12 times 1 minus r is equal to 6. If we distribute the 12, we'll get 12 minus 12r equals 6. From there, we will get negative 12r equals negative 6. Dividing by a negative 12, we get that r is equal to 1/2. And it's not asking us to rewrite the equation, it's just asking us to find the ratio, so there's the answer. The last thing we're going to go over is how to write repeating decimals as fractions. So the first thing that we want to do with these is to rewrite the repeating decimal as a geometric series or an infinite geometric series. So first we're going to look at these first two terms, 0.32. We can write that as 32 times 0.01. The next two terms we want to look at are the third and fourth, and we can rewrite that as 32 times 0.0001. We can do the same thing if we take the fifth and sixth terms, which is 32 times 0.12345, and we could go on like that forever. So, excuse me, what you'll notice is that this section here is 0.01 to the first power. This section here is 0.01 squared. This one here, 0.01 to the third power. So we have now just determined that our R value is 0.01. Now we can use the rule for the sum, and we know that S equals A1 over 1 minus R. So our A1 value is 0.32, which is this one here. Divide that by 1 minus 0.01, which we found to be R. That equals 0.32 divided by 0.99. Unfortunately, there's not a whole lot of simplifying we can do there, so we get 32 over 99. Quick review for this lesson. We need to remember to keep track of those formulas for the geometric sequence because it will come in handy to solve the infinite geometric series problems. And if you have an infinite geometric series, that means that it has a sum if the absolute value of r, or the ratio, is less than 1. And if you have an infinite geometric series with a sum, then the sum is given by the equation S equals A1 over 1 minus R.